Chromatography is a technique used in chemistry to separate mixtures. Once separated, their retention factor can be calculated to identify the individual components of the mixture. This experiment used chromatography paper and the solvent water to separate a coloured dye. Chromatography requires a stationary phase and a mobile phase. The chromatography paper is the stationary phase and the water is the mobile phase. When you apply the ink onto the chromatography paper, it soaks into the surface of the paper. The ink is absorbed onto the surface of the paper. This means there's a chemical interaction between the paper and the ink. These forces hold the ink in place on the paper. The forces of attraction may be weak or strong, depending on the stationary phase and the ink you used. When the paper comes into contact with the water solvent in the beaker, the water solvent begins to travel up the paper. The mobile phase is drawn through the stationary phase. When the water solvent meets the drop of ink, the ink starts to move up the paper as well. The ink has dissolved into the mobile phase, the water, and is moving along with it. There are forces of attraction between the ink and the solvent water that make this happen. Now let's look what's happening under the microscope. Here we can see the atoms that make up the chromatography paper. The ink droplet lands on the surface of the paper and is adsorbed onto it. If we zoom in even more, we can see there are weak chemical interactions between the paper and the ink that holds it in place. When we add the paper into the water solvent, water molecules travel up the paper and surround the ink droplet. Strong chemical interactions form between the ink and the water molecules. As long as the paper is in the water solvent, new water molecules come in from the bottom of the paper and travel upwards. Eventually, the ink droplet will dissolve in the water solvent and travel up the paper with the water molecules. As the ink moves, it then forms new interactions with the surface of the paper. The ink droplet comes out of solution as these interactions form. The ink stops moving temporarily. This process of the ink droplet forming strong interactions with the water molecules, dissolving in the water solvent and travelling up the paper, then forming new interactions with the paper and coming out of solution, continues. The ink moves up the paper as a result. The ink does not travel as far up the paper as the water, and the ink spreads out slightly from its first small drop. This is happening because the ink has not perfectly dissolved into the water solvent, and the interactions between the paper and the ink stop the ink from moving as much as the water. The stronger the interactions between the paper and ink, the less far the ink travels. The stronger the forces of attraction are between the ink and the stationary phase, the longer it will be retained by the stationary phase. The opposite is true for the mobile phase. This is where the name retention factor comes from. The retention factor is a measure of the forces of attraction between the ink and the stationary phase, and the ink and the mobile phase. The retention factor is a calculation. It's the distance the ink travelled divided by the distance the mobile phase travelled. This means it's always less than 1. The retention factor will always be the same if the same mobile and stationary phases are used on the same ink, and the experiment conditions like temperature are kept constant. We can therefore use the retention factor to compare and analyse our results, and work out what makes up the inks that we use. If your classmate told you that their ink drop moved 6 centimetres up the paper and yours only moved up 4, does that mean that the two ink drops are different? No, it doesn't. As we saw in the experiment, the ink droplet and the mobile phase carried on moving up the stationary phase with time. So that means if you leave the experiment running longer, you'd expect the ink to travel further up the paper. To figure out if you have the same ink as your classmate, you need to know the retention factor.